Okay, so this is a question for relative motion, and one in which it becomes really important to understand the motion, and this is one I did in class. I'll go through it again here. You have a speedboat pulling a water skier, and the speedboat itself has a speed VB. This is its absolute speed. And you have a water skier who, according to the question, cuts across the wake of the boat to which has a given velocity, and we know a bit about the position of the skier with respect to the boat. So the absolute speed of the skier, you can tell that by the path that's shown in the diagram and the direction in which the skis are facing. So we write that as VA. Now, the important thing here is to note that because it's connected by this rigid bar, then the motion of the water skier is constricted to this circle of radius 10 meters, and its relative speed is then going to be tangential to this. So the speed that the skier can make with respect to the boat, or VA with respect to B, is going to be in this direction, tangential to the radius. And once you know this vector and these other two vectors, and the question becomes a lot simpler, and we can actually understand the motion by then just repeating these vectors in a separate diagram. So we have VA, you have then, should be VB, then you have VA, and in relative motion you always have those two coming from the same point. So VA like this, and then the relative motion of VA with respect to V completes the triangle. And the question basically revolves around finding the dimensions of this triangle. And we need to take the angles that we know, and we can start to see some of the angles. We know, for example, that the angle between VA and VB is 20 degrees, and that can be worked out by considering that theta is 30. We know theta is 30, it's shown in the question. We know that the horizontal, that line is perpendicular to a line cutting through the angle between the rope and the direction of the skier. We know that this total angle is 50. And since we only need this component here, the angle between VA and VB, we can work that out to be 20. So this one is 20. We need at least one more angle, of course. And we know that the easiest angle to find is this one, because we know that this is 90 degrees because it's perpendicular, and since we know that this is 50, we can work out that this is 40, and so 40 plus the 20 that we had before is 60, so we know that this is 60. If that's 60, then of course that's 120. And as I've drawn below, if that's 20, 120, then this must be 40, and then the question is simply finding the dimensions of the sides. Now, of course, I've said this before, the key point is the motion is constricted by the rope. The rope can't extend, so the radial component of the velocity is 0. So there can be no velocity of the skier in this radial direction with respect to the boat. So we know that the speed of the skier with respect to the boat, A/B, is r theta dot. R is 10, theta dot. And to find the vector VA, we need to know VB and VA with respect to VB. So since we have this triangle, which I've explained above, we then simply just substitute the values in using the sine rule. So the sine rule is sine 40, sine of this angle, divided by this length is equal to sine of this angle divided by this length. And this allows us to get an expression for VA, which is equal to 22.5 meters per second. And once we know this, because we know VB and VA, we can work out VAB. In exactly the same way, using the sine rule, we can find VAB to be 8.87 meters per second. And since we know VAB now, we can use our previous link to say that we know VAB, we know R, so theta dot can be found to be 0.887 radians per second.